Dear students, see the next one from 12th standard in Semiconductor chapter, half-wave rectifier. Okay, listen. So here, you know that this is AC. When the passing through the half-wave rectifier, then output is the half of the AC rectified. We can get DC output like this, like pulsating DC output, like a pulse. Okay, so pulsating DC output. So this is AC, input is AC, but output is converted as a DC. Okay, not only that, it is half of the wave only, so it is called as half wave rectifier. Half wave rectifier. So now we are going to discuss half wave rectifier only. Listen, say for example, you know very well that AC source. That AC source voltage range, that is 220 to 240 range. Some fluctuation is there. But if you know that diode that is breakdown voltage, that is a 6.6, 6.7, or maybe up to 9 voltage something only. But AC source voltage is 220. But diode approximately 9 voltage or 6 voltage. Suppose here the diode is there. When you pass the AC current or AC voltage, this is a diode. Okay, suppose this is a AC source symbol. Okay, suppose if I pass the AC source here like this, directly if I connect it means, you know that this is 220 voltage. Okay, this is maybe 6 voltage only its capacity. Okay, so if we pass the directly 220 voltage to this diode means surely it will be break. Okay, well, surely it will be burn out. Okay, then what we'll do? So we want to reduce that voltage. Okay, so you know very well the process name is when the AC is converted into the DC is nothing but that is rectification, that is a rectifier. But high voltage to low voltage means, yes, that is transformer. So we must use transformer. Not only that, here higher voltage converted into the lower voltage, so you should use step down transformer first. Okay, so through the step down transformer only we can pass the current and that voltage, that AC. See that here also, if I open the cell phone charger, now this is connected with these two terminals will be connected with directly the plug point. Okay, directly it is connected with the AC. Okay, so if you open this box, okay, this AC current immediately very first join with the transformer only, that is step down transformer. So that step down transformer reduce the voltage according to our convenience. Okay, right. So now we can discuss that half wave rectifier. First, transformer. Okay, so we know that different type of step up transformer, step down transformer is there. So now in the case we need low voltage only, so I can use step down transformer. Then step down transformer, generally in the transformer, the primary coil and secondary coil is there. Okay, so first in the primary coil, okay, then this is no secondary coil. So if you observe, very well, the comparing with the primary in the secondary, so this is primary, so I can write P1, this end is P2, secondary S1, this end is S2. Here we know very well that a transformer electromagnetic induction. So here the mutual inductance is represented by this line. Okay, right. Then this is in that number of turns in the primary, here number of turns in the secondary. Okay, so if you observe that number of turns primary is greater than number of turns in secondary, so so that means here the voltage also high. Okay, voltage in primary is greater than voltage in the secondary. Okay, because the number of turns and the voltage is like some corresponding. Okay, if the number of turns is more, voltage also more. If the number of turns is less, voltage also less. So this is surely now step down transformer. Step down transformer. So it is connected with the AC source signal. Okay, sinusoidal source, AC source. Let's say AC signal. Let's say AC source. Okay. Now I can connect it with one diode here. Okay, PN region. Okay, right. Okay, here high voltage. Here the voltage is reduced. Now here the process happen. Then how we can get that output from the circuit? So whenever we can get the output through the load resistance, like a downloading. Okay, so that two load resistance is here. That load resistance I can mention by, okay, that is RL, that is a load resistance. See students, now, so now we know that in the AC source, for every second, okay, it will change it, okay, it will change its cycle, positive, negative, positive cycle, positive, negative, because you know that AC, what is it, frequency, no, okay, the 50 hertz in our country. So so every second, so the per second 50 times change the cycle, positive cycle, positive, negative, positive, negative, positive, negative, like that. So let us imagine, suppose it is a positive, so here also positive. Listen, so here positive, here also positive, negative, here also negative. So let us imagine now. Okay. So now voltage is reduced. Now the positive signal passing through the diode. Okay. So now I can explain with the wave diagram. Okay. I think okay, fair enough. Okay, please listen. So simultaneously I draw the diagram for both input and output, and only okay, so this is for, that is the input AC. Okay, this is input AC. Okay, so I mention like this, input AC. Okay, this is AC symbol. Okay, otherwise I can write input AC. Then this is output, that is DC. Okay, so can properly maintaining that time gap and phase. So simply I put some dotted line for our convenient. Okay, so this is it's a voltage. Okay, voltage for AC, voltage for DC. Then generally that is omega T, that factor. Okay, so very well from AC lesson. Okay, please listen students, now that now we can pass that forward bias, I mean positive cycle current. Okay, when we observe that here AC, here positive means here negative. Okay, so positive, this is positive cycle. At the same time here the negative cycle. So positive, then negative. So very well, positive to positive, negative to negative, it is acting as forward bias. Okay, see that this wave, for example, it is the positive wave here. For example, negative wave here. So positive, negative to negative. So now it is acting as forward bias. So in the forward bias, that diode offering low voltage and allow the current also. So due to that, so this is input, generally input signal, positive, negative, positive, negative. So it is like input signal. So we have to analyze inch by inch, okay, for every cycle. So now let us imagine now it is a positive cycle is running. So now the diode is working. So here I can use only one diode. So simply I put a diode. So now this diode is accepting this positive cycle. So here we can get curve. Okay. Suppose in the case of here the negative. So here the negative, here, sorry, correct only. It is a positive, this positive, it is negative. Okay. So here negative to positive, here positive to negative. So this is now is reverse bias, but practically no current. Okay, but little current is there in reverse bias we study, but it's not that much use because due to that minority charging area. So this is like off condition. Then again cycle change. Again cycle change. Here the positive will come. Then here negative. Okay. So now again it is acting as forward bias. Again diode is working now. That's all. So now see that this is that output voltage is DC. Then half of the wave only coming out. It is not like continuously. Due to some gap only will come. So that only we called as that is pulsating like a pulse. Okay. So it is a pulsating output to DC voltage. Okay. Okay, students. Then so I hope how the diode is acting as a rectifier, you know very well. Then one more point. So in the half-wave rectifier, we can say that efficiency. So generally, that efficiency is equal to output divided by input. Okay. So we can say DC output power divided by AC input power. So this is known as the efficiency of rectifier. If you need in the percentage, you can multiply with the 100. Okay. Generally, its efficiency generally, and approximately we can say that is a 40.6%. So this is the efficiency of half-wave rectifier.